let's take notes. 7.3 part 1. Oh, come here. That means, like, pick a letter to use and tell me what it means. You know, like pounds, something like that, or ounces of paint. I don't know. Alright, so 7.3, we're going to multiply radical expressions. So let's look at a little example here to see what I'm going to show you. So what if we took the square root of 4 and multiplied it by the square root of 25? So people are always wanting to look for ways to simplify things. Do you guys think that we can multiply these together and make it the square root of 100? Let's check. Let's see if it works. What is the square root of 100? 10. What is the square root of 4? What's the square root of 25? What's 2 times 5? 10. So it works. It is okay to do that. So if you have two roots being multiplied by each other, you can multiply the things inside of it and just make it into one root. Now, the only trick is that it has to be the same kind of root. So see how this is a square root and this is a square root, and we made it into a square root? It would not work if this was like a cube root. They have to both be the same kind of root for this to work. So we're going to write something and put it in a box that's important. So if we have, say, the nth root of A times the nth root of B, so same type of root, like maybe they're both cube roots or something, then we can put those into one root and just multiply A times B inside of it. And that's going to help us simplify these a lot. My notes only take up one side of one piece of paper today. That hardly ever happens. Alright, so our first example, we are going to just multiply. So the instructions just say multiply. So our first one is going to be the square root of 2 times the square root of 7. Yeah, go ahead. No, you can leave under square root. Yeah. So raise your hand. What is this one when I multiply it? Elise? Perfect. Square root of 14. You just multiply them together and put them in a square root. It's pretty easy, but they're going to get way harder. No, you don't have to. If I wanted you to, I'd give you a calculator. Because square root of 14. Right, if it was 9, you would. Yeah. Alright, so second one, we're going to do the square root of x plus 3 times the square root of x minus 3. So they're both square roots, right? So you can put them together in one. So let's do that. You can put them together in one because they're both square roots. Raise your hand. Does anyone know a shortcut of how we could multiply those? Elise? Yeah, this is a factored out version of difference of squares. So what does it end up? Do you know, Elise? Perfect. There we go. So she went backwards. She recognized that this is a difference of squares. So she like undid the factoring. Went backwards. You could FOIL it out and multiply it all, and you would just end up with this. Charlie? No, because that would not be, because a difference of squares has to be a minus. So that's a good question. It has to be a minus to a difference of squares. All right, we got one more before some more notes. Actually, there's like not really any more notes. It's just all examples. So we've got 1, 2, 3, 4, 5, 6, 7 more examples. All right, this one we're going to do the fourth root of y over 5 times the fourth root of 7 over x. So remember, you guys try it. They're the same type of root, so you just put them together. Just multiply y fifths times 7x. That's hard to say. Like, I'm trying to say tenths, but say x. Try it, Clay. No, not try saying it. Try doing it. All right, so this shouldn't be too hard because we know how to multiply fractions, right? So on this one, all we do is put them into 1/4 root. On top, we've got y times 7, which is just 7y. And on bottom, we have 5 times x, which is 5x. That's it. Like, that's all it wants you to do. It's not. These are not bad yet. Not bad yet. Okay, now I'm like debating how to teach you these next things. I'm going to show you like a bunch of different ways, and you pick your favorite ways to do it. Okay, I really like these next kind of problems. All right, so these next examples, we are going to simplify by factoring. I tried to like start off easy and then get tougher because the easy ones are really easy, the tougher ones are really tough. So I'm going to show you several different ways to do these. So the first example is a kind of easy one, the square root of 200. So we're trying to see if we can write this as an easier, a shorter thing. So what we're kind of looking for is, here's one way to do it. I'll do the first way in red. Can you think of any perfect squares that are factors of 200? Cameron? 100, right? So let's rewrite this. This is just in here 2 times 100, right? So this is option 1 of a way to do it. Now, what we learned is that we can split this up. We know that if we have the nth root of AB, we can split this up into nth root of A times the nth root of B. I would write that off to the side, yeah. It's just backwards of what we wrote in the box before. It's saying you can split them up into 2 different roots instead of putting them together into 1 if you want. So you can work either way. Split them up or put them together into 1. So what that's telling us is that we can split this into 2 square roots. The square root of 2 times the square root of 100. Do we know the square root of 100? 10. So what we can write is just 10 square root of 2. And that's our answer. Yeah? You could. Yep. So let me show you guys another way. So I'm going to do the same problem in another way. And I would write this out even if you like that way. This is, what I'm about to do is my favorite way. Now they're going to get a lot tougher because we're going to put variables in it. But this is my favorite way to do it. So the way I learned when I was in school is that you make like a factor tree. So like let's say we didn't, for some reason we didn't remember that 100 times 2 is 200. We can do whatever numbers you want that multiply to 200. Like Tyler said 25 and 4. So we can do 25, no, sorry, 25 times 8, right? 25 times 8. We could do that. You could do whatever numbers you want. It'll always work. Now you want to keep factoring until you can't anymore. So let's see, what multiplies to 25? 5 and 5. And then 5 is prime, so like those are the leaves at the end of the tree. Does anything multiply to 8? 2 and 4. Can we break either of those down anymore? The 4, what multiplies to 4? 2 and 2. So here's what you do then. I feel like you guys are like looking at this like you don't want to do it this way, which is fine. This is just my favorite way. Okay, so since we're doing a square root, like there's technically a little invisible 2 right there, right? We're looking for groups of 2 that came out of our factor tree. So we had a group of 2 5s, and we had a group of 2s. They get to all come out. So if they have a friend, they get to come outside. Okay? So, but if they didn't have anyone to pair up with, you can put it in a box instead. He has to stay inside. He didn't have any friends to go outside with. So the 5 gets to come outside. You only write him once. The 2 gets to come outside, so you write times 2. This 2 didn't have any friends. He had to stay inside the square root. And then we just simplify the 5 times 2, which is 10. I know it does. So it's up to you. I like this way better. I don't know. If you can't think of any perfect squares that go in it, then this might be easier. Yeah? Because he didn't have any friends to pair up with. He was not circled. But 4 split up. So we're only looking at the very end numbers. So only the end guys are the ones that we are looking at. Are they pairs? And they both have to go on the inside. And you multiply them together. Multiply them together. Liv? It works for cube roots too. Let's do a cube root one. Well, actually, we're going to do another square root because we're going to work our way up slowly because these are tough. Okay. Are you ready for another one? If you're not 100% getting it, it's okay. That's why I'm doing tons of examples. All right. Second example. Square root of 50 x squared y. I know, and right now I'm like, do I even want to put the letters in it already? Let's do it. Let's just try it. So we're going to work with it in totally separate parts. So let's just do the square root of 50, and then we're going to do the square root of the x squared, and then we'll do the square root of the y. So I just split it up. I'm going to deal with them all separately, and then at the end we'll put them back together. So if you guys don't like the tree way, we don't have to use it. So 50. Can you think of any perfect squares that go into 50? 25. So we can write this as the square root of 25 times the square root of 2, because 25 times 2 is 50. Let me give you like a second to digest that. Is that okay so far? Maybe you need some probiotics if you can't. Yes? This is a perfect square, right? Well, we can't find anything that's the same number to get 50, right? If you could, you would do it, but we can't. So we want to simplify as much as we can. We want to pull out as many squares as we can. Right. So now, do we know on this one, what's the square root of 25? 5. And this one can't be simplified anymore, right? It's prime. So this is 5 square root 2. Yeah? What do you mean? Oh, it's 5 times the square root of 2. Is that what you're asking? Well, it means... So what it means is we're going to do 5 times whatever the square root of 2 is. And the reason it works is because we learned that if we have something in a square root, we can split it up into 2 square roots if we want. Does that make sense? Let's just keep doing more. Let's just keep doing a bunch of them. So if we had just been given this as our problem, this would be our answer. But we also had these x's and y's in it. Yes. Yeah, I'll do the tree way right after we finish this. So on this one's easy. What's the square root of x squared? X. We're going to put it together at the end. Isn't the square root of x squared x? Because a square root and a square cancel each other out. You don't have to if you already know the square root of it. Like, if this had been the square root of 100, you wouldn't have to write square root of 10 times square root of 10. You would just write 10, because we know the square root of it. Now, what about this one? Can we simplify the square root of y anymore? No. So this is just square root of y. Now, we have to put all of these together. This is kind of the tricky part. This is why I like the tree method. I don't like doing it this way. So we're going to look at anything that was on the outside of a square root, anything that was on the inside. So if we go through all the parts of our answer, see how we have a 5 that's not in a square root and an x that's not in a square root? So 5x goes on the outside. Now on the inside of our square root, what was left? A 2 and a y. So 2y goes on the inside of our square root, and that's our answer. No, I'll show you the tree method now. No, that was not tree. This is the way you guys said you wanted to do it. All right, so if I was doing tree method, here's what I would do. Okay, so you got to keep in the back of your mind the whole time, I'm looking for pairs of 2. It's a square root. I'm looking for pairs of 2 to come outside. If it's a group of 2, they get to come out. So let's see. I would say, okay, 50 is 25 times 2, and 25 is 5 times 5. These guys are coming out. This guy is staying inside. Does that part make sense? So then x squared is x times x, right? He's a pair. He gets to come outside. Y is just y. He doesn't have any friends. He has to stay inside. So then I go through, and this is the trickiest part. Anything that's a pair, you just put one of them on the outside to show that he got to come out. 5 got to come out. X got to come out. 5x. 2y stays inside. 2y stays inside. So that's the tree way. It's up to you, yeah? A perfect square? No, you don't have to. If you did 5, so let's say for the square root of 50, which we know should end up 5 square root 2, you guys should keep paying attention even when someone else has a question. So if we did square root of 50, you don't have to unless you want to. If you had decided instead to break it up into 5 and 10, then you would have break the 10 up into what? 5 and 2. Now, even though these guys are on like different branches, they still are friends and they get to come out. So a 5 gets to come out. This 2 didn't have any friends. He stays on the inside. 5 on the outside, 2 on the inside. Let's do another one of just a number. Which example is this now? C? I'm just going to do a random number. Let's do the square root of 68. This one I didn't have planned out, but I feel like it's good to do another easier one. 4 times 4 is 16. So let's try the tree way. Raise your hand and give me 2 numbers that multiply up to 68. Shh, Liv. No, it's 64. Zach? 34 and 2. No, you don't have to. But I can't think of any perfect squares, at least in my head, that multiply to 68. You might be able to. I can't. Yeah? Right, or you could just be like, oh, the square root of 64 is 8. Oh, good question. You would stop. As soon as you can circle things up as friends, you circle them. So then, what about 34? Raise your hand. What multiplies to 34? Jake? 2 and 17. Do you see any friends? Twos are friends. Can you break up 17 anymore? Is he prime? He's prime. 17 stays inside by himself. So 2 comes out. You only write him once, though. and 17 stays on the inside. So that's why I think that one was a little, like, I maybe wouldn't have thought right away, oh, 4 is the biggest perfect square that goes into that. And we did the square root of 4, which was 2. Like, that's why I like the tree way. Do you want to do another simple one with the tree thing? Let's move on to a cubed one. So when we do a cubed one, I think you're going to see why I like the tree way. Well, that's too bad. Alright, let's try another one. We're going to do a cube root this time. Oh no. Alright, write this down. The cube root of negative 72. First of all, let's just decide on what the sign of our answer is going to be. If we do the cube root of a negative, if we do the cube root of a negative, is our answer going to be positive or negative? Negative. So let's just write a negative down so you remember your answer is negative. Now, you can either decide to do it the tree way or the not tree way. If you're doing it the tree way, here's why I like the tree way for like anything more than a square root. Now we're looking for pairs of 3 who get to come outside. This means they have to have 3 friends to come out. So let's see. Give me some things that multiply to 72. Raise your hand with 2 numbers that multiply to 72. Yeah? And since we already decided about the negative, you don't have to worry about the negative anymore. So 12 and 6. Let's see. Can you break either of those down more? Yeah. What multiplies to 6? Okay. 6 and 2. You guys are getting ahead and people aren't going to be able to catch up. Raise your hand. What's something that multiplies to 12 that you want to use? You can do whatever you want. Elise? You need to raise your hand if I ask you to raise your hand, okay? 3 and 4. Raise your hand. Are there any of those that we can break up any more? Esther? What is it? Perfect. 2 and 2. Okay, now look at all of your ending numbers, like the leaves. We're looking for 3 friends who can group up together. Are there any 3 friends, Liv? 2. These guys are a group of 3 friends. He gets to come out. Now, our other ending, like the leaves on the tree, this 3 and this 3, they don't get to come out because they don't have a group of 3. So they have to stay on the inside. So on the outside, remember our answer is going to be negative. Negative, the 2 gets to come out because he had a group of 3 friends. On the inside, make sure you keep this a cube root. You can't change it to a square root now. It has to stay a cube root. On the inside, when you're putting the guy on the outside, you only write it down once for the whole group. On the inside, anything that had a box has to go in here. So we've got 3 times 3. Always multiplying. So then we're going to simplify it and do 3 times 3 on the inside, which is 9. So this answer is negative 2 times the cube root of 9. The cube root of 9 is not 3. The square root of 9 is 3. So when you guys, we're not done yet, but when you're doing your homework, you guys need to work very carefully. Okay, let's do a harder one. We're going to do the 4th root of 162x. And you know what? If you ever have variables in it, I recommend when you write down the problem, if you're going to do tree way, which I recommend, just leave a bunch of space in here. 162x to the 6th. Now, when you get it in your book, it's going to look like this. But I like to write it this way, so I've got lots of room for my trees. So now, this is a 4th root. We're looking for friends with a 4, a group of 4 who gets to come outside now. Okay, so let's start breaking it down. Raise your hand if you can give me 2 numbers that multiply to equal 162. You have to raise your hand to give me numbers that multiply to 162. Sweta? 81 times 2. You don't ever want to do 1 because you can't ever use the 1 later. So don't do times 1. Raise your hand if you can break down either of those anymore. Elise? 9 times 9 for 81. Raise your hand if you can break down any of those anymore. Clay? Good. The 9s are each 3 and 3. And now we're down to all primes, right? 2 is prime, the 3s are prime. So, are there any groups of 4 friends who get to come outside? The 3s. It's fine. So this group of 4 3s gets to come out. The 2 has to stay inside. Now, if I were you, I just hold off until we finish the x's, and then we'll write our answer all at once. So for the x's, there's easier ways to do it. Like when you start getting used to it, you'll be like, oh yeah, that's easy. But I think the best way maybe to do it is, for now, let's just do this. I know you're going to think it's silly. X to the 6th is 1, 2, 3, 4, 5, 6 x's. Are there any groups of 4? Yeah. So that group gets to come out. Both of these guys have to stay inside. You could do that. You could do x squared. No, you'd have to do x squared times x to the 4th, because that would give you x to the 6th. But for the letters, I would just do this. So now let's see who gets to come outside. 3 gets to come out. X gets to come out. On the inside, what kind of root is this? A square root? A 4th root. On the inside, the 2 had to stay inside, and x times another x. So on the inside is 2 times x times another x, because this 2, this x, this x. Shh. Stop trying to jump ahead. So then, since we can simplify what's in here, we want to. So we've got 3x on the outside times the 4th root of 2x squared. That's your answer. I know these get a little complicated, that's why I made them short today. I was supposed to do like way more stuff today.
This is not short.
I know.
There's more?
Yep, we're doing 2 more. Actually, I'll just do this as the last example, I think. I'll do one more while everyone else works quietly. And if you want to write it down, you can. Alright, so on this one, we're just looking for pairs of 2. So let's start. 18 is 2 times 9, and 9 is 3 times 3, right? So he gets to come out. He stays in. So that's 18. For the A, it's just an A. He has no friends, no pairs, so he stays in. I put him in a square. He stays in. Because the A is just A. He had no pairs. And then B is B times B, and he's a pair. So on the outside, I've got the 3B. You only write them once on the outside, even though we circled 2 of them. You only write them once. And then on the inside of my square root, I've got 2A. Does anyone want to do one more?
No.
Okay, so if you don't want to do it, you don't have to. You just start working absolutely silently. You're not talking. I'm doing one more up here for people who want to listen to it. So one last one. It is the square root of 75y to the 5th. Shh. If you're working absolutely silently. That means no talking at all. No talking. Zero talking. Just a second. Alright, so this one breaks down. We can do, let's see, 75 is, what can we break 75 into? 25 times 3? And then 25 is just, whoops, 5 times 5. And that's all I can break 75 down. So we're looking for pairs of 2 because it's a square root. So we take out the 5's, the 3 stays in. And then y to the 5th is just 5 y's multiplied. 1, 2, 3, 4, 5. Pair, pair, stay. So you're looking for pairs. So on this one, let's see outside. A 5, a y, and another y get to come on the outside. So 5 times y are all on the outside. On the inside of my square root is a 3 and a y. 3y. So if I simplify that, I've got 5y squared and then square root of 3y. Okay, so you guys can start your homework. I'm gonna, if you guys could, please